Suddenly, now we were cut. Sorry again. Now the value of our charge, guys, now they are all equivalent to 1 microcoulomb. So these are three charges that are basically equal. They are positioned in positions A, B, and C, and they are 1 meter away from each other. Now earlier we established that the angle in our triangle inside here are 60 degrees. Now they are all 60 degrees because this is an equilateral triangle. An equilateral triangle is also called as an equiangular triangle. So if this is 60 degrees below, and we have a line here that is that are parallel, then if they are cut by a transversal, then their corresponding angles must be equal. And then somewhere here, now we will see that this is probably our F2. We could call this as F sub 2. There's a force here we can call as F2. And on the far end, the other pointing line there could be called as F sub 1. So our forces are responsible. They are repulsion because they are both positive charges. So 1 microcoulomb each. So our charges, we can call it as Q sub A. I just call it with small letter. Q sub B and Q sub C. They are all 1 microcoulomb. So 1 microcoulomb is 10 to the negative 6 coulomb. So that's how much is a microcoulomb. They are all equivalent. Now their distances, so maybe we can call it as R sub A. RA is equals to RB, and equals to R sub C. And they are all 1 meter apart. So therefore, based on this charge value and their distance, we can compute for F1. We can solve for F1, and we can solve likewise for F sub 2. And we can simply use the equation of Coulomb. So how much will we get for F1 and F2? So starting with F1, we know K to be 9 times 10 to the positive 9. That's Newton. So this is positive 9. Okay, of course, that's an exponent. And then we multiply it with our value. This is 1 times 10 to the minus 6, or we can just write it as 10 to the negative 6. That's Coulomb. And then another 10 to the negative 6 Coulomb. And we divide it with our value, distance 1 meter. But we have to square 1 meter because R is being squared in our expression. So we will draw our line here. And since the unit there is, and since we are solving for F, then we will get a Newton answer. Okay, so that's squared quantity. And can somebody please calculate for me this value? I think it's similar to our answer earlier. So F1 being similar to the magnitude of F2. So we will have, earlier we have a value 9 times 10 to minus 3. And the answer there is in Newton. So F1 and F2 are of this quantity, but they are now creating an angle. They are not simply in one straight line. Now, if we deal with charge F1, F1 is the relationship or the force due to charge A and B. So F1 will be going up. The same way, ini nga value sa dalom, this must be also F1. Now, what is this force going left? This is due to the force created by charges B with respect to C. So charge B and C, now they will also repel. So this is the force that they will have. But you'll notice that all these arrows here have the same magnitude. They must have the same magnitude, no? Except that what we have now, we want to find the net force, no? Or the resultant force that is created by, no, our charge F1, no? Or our force F1 and F2, no? Now, if we use our component method, no, since we know the magnitude already, so if we use our component method, then we can get, no, first we can get F1x, and no, we know F1x to be F1, no, cosine of 60 degrees, no, and F1, if you look at F1, no, it's going to the right, it's pointing right, so this must be a positive answer, no, positive ni nga to nga sign sa iya, no. We can calculate that, no? So these are the forces on the x-axis. And then we can also have F2x, no? Which is of course, no, negative this time because this is going left, no? So F2 cosine still of cosine of 60 degrees, no? Because it's going left, no, ang direction niya, no? Now, if they are of the same magnitude and then they have the same angle, no, and they have the same magnitude, then most likely they have the same answer, and the sum of the two, no, if we get the total, no, which we will call as fx, our fx value, guys, no, our total force in the x-axis must be 0. Okay, we know that they will eventually have the same answer. Okay, f1 and f2 are of the same magnitude, and if they are separated by a sign f1, no, positive, and the other one is negative, then the sum of fx must be 0, no? Now, if we go to fy, no, or f sub y, f sub f1y, no, f1y is our y-axis value, no? So they will be both positive. That's f1 sine of 60. So they must have the same value, no? And f sub 2 must also be, no, f2y, I mean, also be positive f2 sine of sine of 60 degrees. Huh? Okay, then you'll see that you will have the same sign here, and your f2 now will fy now will no longer be 0. Now, can you please calculate for me now the value, the total of fy1 and f2, f1y and f2y. No? So this is on the vertical axis. No? So ang duwa na force natin, if you try to draw it, no, it probably appear this way. So f1x, no, is going somewhere here, and your f1y is going up, no? And on this side, amo na ni mo karon nga resultant, no? Okay, so since both of these forces are going up, no, in the same direction, then you will simply add them both, no? Amo ni atong resultant ang sa kilid niya. Okay, so we combine together all the y values and all the x value, no? Sige, how much is our fy, no? Can somebody calculate for me? F1 is again, no, 9 times 10 to the minus 3. F2 is also equal in value. No? Can someone please multiply? No? So F1 and F2 are the same in magnitude. No? Okay, Fy is how much? Okay, somebody trying to solve there. Okay, I'll just use this one. No? So they are both now same or equal in magnitude. No? So they must be both. No? Okay, so they are both equal. So we double this value. No? If you try to double that, no? If you add f1y and f2y, then the doubled value is total value. So to get the resultant, no? So what's the resultant? Maybe you can call it as f sub r. So resultant is equals to the square root, no? Of fx square plus y square, no? And we extract the square root, no? So this is how we get the resultant by our, no, component method. And again, we square both of them. You'll notice since this is 0 and this is 0.0156 and you square it, no? You'll notice that f sub r will eventually end up, no, equivalent to, no? So your fr value will be equivalent to, no, 0.0156 Newton. No? Manang sabat na to, no? And if you write that in scientific notation, then maybe you can have 15.6, no, millinewton, no? Or in scientific notation again, no? You can write that as 15.6 times 10 to minus 3. No? Again, either you can call it milli or you can write it as this value, but there's a small final force, no, that exists between the two. So if you will get the angle, I believe, no, the final direction of your resultant will be going upward. No? Diri pa kadto yung mga, so this force, so this charge will move up, no, straight up like that. No? Dira siya pa kadto yung mga direction niya na. No? Okay, since it is being repelled by these two charge below. No? So it is going up, no, 90 degrees straight upward. No? Kaya equal, malang balanse, malang kada kilid niya. Okay, so this is how we realize, no, the effect, no, or the application of Coulomb's law. No? And moving on, no? So maybe we can delete this, no? Erase, no? So that's an application of our problem, no? On, no? Coulomb's law. So the knowledge that we already have in physics 1 is useful, no, in finding our force here. No? So our answer there, no, is simply equal to our earlier answer. No? So here's our value, no? But we have a different answer here. No? No? Let's look at how our answer is. Okay, so that's not 1 Coulomb, but that's 1 microcoulomb. No? So I think the assignment of the unit of our charge is kind of wrong. No? So we are not dealing with, no, 1 Coulomb, but 1 micro. No, you see this mu symbol. So this must be, no, erroneous, no, because of the assignment of the value or force. But somehow it's around, no, 1.56. So 15.6 ang sabat natin. But with regards to the exponent 10 to the positive 10 is wrong. No? This one is quite wrong. No? But this is again, no, going in the y-axis. No? So this is pointing, no, direction of positive y-axis. So this is merely going upward. No? So that's the effect of our charge. No? Okay, there were two, no, things nga ginpasolve ko kaina. So maybe now this is the end of our problem here. So I want you to try this. Instead siguro of the other previous problem, no, we can try this one. Again, no, you may answer this, no? And you can go to our email, no? So I will ask you to answer this in groups of four this time, no? Four members in one group, and you can answer this item, no? Any question from you? So you can choose your group members, no?